Welcome to General Physics 1. Our first topic is the introduction to physics, to be followed by units of measurements. You could view physics maybe right after mathematics as the purest of the sciences. So you have math, which is very pure, and then on that foundation of math, you have physics. And physics really does try to use that mathematics along with some core ideas to explain the phenomena. Now, a lot of times, we think physics is only limited to things like cosmological phenomena, or getting rockets into space, or how waves move. But physics is the foundation for all of the other sciences. Now, what is physics? To be honest, it's really difficult to define exactly what physics is. For one, physics keeps changing as we progress and make new discoveries. This makes physics exciting, but it also forces attempts at defining physics into generalization about what physics has been rather than what it might be at some point in the future. Now we will define physics as one of the most fundamental of the sciences. It is also the foundation of all engineering and technology. Also, no engineer could design a flat-screen TV, an interplanetary spacecraft, or even a better mousetrap without first understanding the basic laws of physics. One of the most renowned physicists is Galileo Galilei. He dropped light and heavy objects from the top of the Leaning Tower of Pisa to find out whether their rates of fall were the same or different. Because of this, he made the inductive leap to the principle or theory that the acceleration of a falling body is independent of its weight. Galileo's analysis of falling bodies was greatly extended half a century later by Newton's laws of motion and law of gravitation. So why do we need to be able to measure things? Suppose we wanted to measure a 2x4 for building a house. Numbers by themselves don't make sense. Also, units by themselves don't make sense. To make sense, all measurements need both a number and a unit. Why do we use the SI system? In the US, they use the English or standard system. Most of the rest of the world uses the metric or SI system. The SI system, or International System of Units, is the form of measurement typically used by scientists. Scientists use the SI system worldwide because of the following reasons. Measurements under the International System of Units are easily understood by all scientists. Also, these measurements are easier to convert than the English system. There are three basic types of measurement. The length, which measures the distance between objects. Volume measures the amount of space something takes up. Mass measures the amount of matter in an object. And the other types of measurement include time, temperature, density, and pH. Now we are going to compare the measurement system, the English versus the SI system. Measuring length, mass, volume, temperature, and time, for English system, we use yard or inch for length, and for SI system, we use meter and centimeter. For mass, for the English system, we use ounce and pound, and the SI system, gram and kilogram. Volume, quart for the English system, liter for the SI system. Temperature, Fahrenheit for the English, Celsius or Kelvin for the SI, and time, second, the same with the SI system, second. All measurement systems have standards. Standards are exact quantities that everyone agrees to use as a basis of comparison. In the English system, you have to remember so many numbers. For example, 12 inches in a foot. 3 feet in a yard, 5,280 feet in a mile, 16 ounces in a pound, 4 quarts to a gallon. While in the SI system, you only have to remember one number. The SI system is based on the number 10. The SI system uses the following prefixes: kilo, hecto, deca, deci, centi, and milli. This system works with any SI measurement. The unit becomes whichever type of measurement you are making. For example, in measuring mass, we use gram. For volume, we use liter. And for length, we use meter. It is the same system regardless if you are measuring length, mass, or volume. These prefixes works for all types of measurement. For example, if you're measuring a mass, then it is the gram. Using prefixes, it will become centigram or milligram. So the first part of the term indicates the amount, the second part indicates the type of measurement. Now, if you're measuring length, then it is meter. For example, kilometer and decameter. Now, if you're measuring volume, then it is the liter. For example, deciliter and hectoliter. Okay, so how does converting units work? Unlike the English system, converting in the SI system is very easy. For example, in the English system, if you wanted to know how many inches are there in 2 miles, what would you do? First, you take the number of miles. In our case, we have 2. Then, you multiply it by the number of feet in a mile. So 1 mile is equivalent to 5,280 feet. Now multiply that by the number of inches in a foot. So how to convert 2 miles into inches? So I will show you how to solve. First, you take the number of miles. So that is 2 miles. You write miles as mi. And then you multiply it by the number of feet in a mile. So take note that there are 5,280 feet in 1 mile. Okay, so you have here as your numerator the 5,280 feet and your denominator is 1 mile. Okay, so you place 1 mile as the denominator in order for us to cancel out the units. That's the miles. So you will be left with foot. Now, we are going to convert foot into inches. So, we are going to multiply that by the number of inches in a foot. There are 12 inches in 1 foot. So, you have there 12 inches as your numerator and then 1 foot as your denominator. This is to cancel out the unit foot. Okay. Now you will be left with the unit inches or inch. So performing the operation, you will get 126,720 inches. So the answer is there are 126,720 inches in 2 miles. Now here, the SI system is much easier than the English system. For example, in the metric or SI system, if you wanted to know how many centimeters were in 3 meters, what are you going to do? So first, you find the unit you have. Okay, so we have here 3 meters. Now find the unit you are changing to. So that's centimeters. Okay, so please do refer at the lower side of the slide. You can see there the kilo, hecto, deca, unit, deci, centi, and milli. Now we consider here your unit as the meters. Okay, now count the number of units in between. So how many number of units are there in between meters and centimeters? So you count from unit to deci, that's 1. Deci to centi, that's 2. Okay. Now move the decimal point that many spaces in the same direction you counted. Since we counted the units going to the right, we will also move the decimal point going to the right twice, okay, or 2 units. So we have there 3 meters is equal to 300 centimeters. Okay, so we have here more conversions. For example, 2,321 millimeters to meters. That's 3 units going to the left. So you have 2.321 meters, and then 521 grams to hectograms. That's 2 units going to the left also. So you have 5.21 hectograms. And then 8.5 kiloliters to centiliters. So kilo to centi, that's 5 units going to the right. So you move your decimal point 5 times. You have now 850,000 centiliters. So here you can observe that the digits aren't changing, but the position of the decimal is. Unlike for the English system, the whole number changes. One of the basic types of measurement in metric system is length. We define length as the distance between 2 points. So it does not matter if it is width, height, depth, etc. All are length measurements. Now the basic unit of length in the SI system is the meter. While in English system, the meter is about the length of the English yard, which is equivalent to 3 feet. A variation of a length measurement is called area. Area is equivalent to length times width, which is expressed in units squared. For example, meter squared, centimeter squared, and millimeter squared. We also have mass. Mass is a measurement of the amount of matter in an object. The basic unit of mass is the gram. There are 454 grams in 1 pound. Gram is the metric system or the SI system, while pound is for the English system. Now mass is different from weight. Weight is the pull of gravity on an object. The greater the mass, the larger the pull of gravity. While volume is a measurement of the amount of space that something takes up. The basic unit for volume is the liter. This unit is used for the volumes of liquids. While for the volumes of solids, we use this formula. Length times width times height. For example, you have the unit for length, centimeter, for width, centimeter, for height, centimeter. Multiply the 3 units, you will get centimeter cube. Now what about for the objects without a definite length, width, or height? For example, a rock. You can use water displacement to determine its volume. Note that 1 milliliter is equivalent to 1 centimeter cube. Also, 1 centimeter cube is the same with 1 cubic centimeter. Or 1 meter cube is also the same with 1 cubic meter. The same with measuring the area, you have 1 meter square is the same with 1 square meter. Another one is the temperature. It is the measurement of the amount of kinetic energy of the atoms in an object. Temperature is measured with a thermometer and has a unit Celsius or Kelvin. Fahrenheit is used for the English system. Celsius ranges from 0 to 100, 0 as the freezing point and 100 as the boiling point. While for the Kelvin scale, it begins at absolute 0. At 0 Kelvin, no more heat can be removed from an object. When converting Celsius to Kelvin, you just add 273 degrees to the Celsius reading. Hence, freezing in Kelvin is 273 Kelvin, while for boiling, it is 373 Kelvin. Now, which do you think is heavier? A kilogram of feathers or a kilogram of lead? Now, which one takes up more space or volume? They are both 1 kilogram, so they weigh the same, but it takes more feathers than lead to equal 1 kilogram. We say the lead is more dense than the feathers. Now we will talk about density. It is how much matter is in something compared to the amount of space it takes up. Hence, the formula for density is mass over volume, or mass divided by volume. It gives us the unit for density, gram over cubic centimeter. Take note that every substance has a density, and that density always remains the same. Density is used to figure out what an unknown substance is. Furthermore, every substance has a specific density. For example, the density of water is equivalent to 1 gram per cubic meter. Now, to sum up our lesson, we had defined that measurements need a number and a unit. There are also 3 basic units of measurement. In metric system, we have meter, liter, and gram. We also performed the conversion of metric units, the same with the English units, and we were able to make basic measurements and calculations of volume, length, and mass. We also defined what is density. Basically, that's mass over volume. And density is used to figure out what an unknown substance is. So that's all for today. Thank you for listening. God bless and excel at all times.